So hello everyone. Today our video is on how to detect a cycle in a graph. So probably you know the basics of a graph, I believe, and this is also a very basic video. So let's say we have a graph something like this, right? So this is an undirected graph. This is an undirected graph. So as you can see that this graph does not have any cycles, right? Now let's say if I join these two vertices, if I join the second and the third vertex, so now there exists a cycle in the graph, right? So how will we detect this cycle? That's a question. So we will be using BFS. Hope you know how do we solve, like how do we use BFS for a graph. So BFS stands for breadth first search. So what we do in BFS, I hope you know how to write the BFS for graphs, right? Like I'll show you a very basic example. Let's say if I remove this edge and I tell you to write the BFS of this graph, so what you will do, so it just goes like level wise scanning, right? So first level is 1, the second level is 2, 3, and this is 4, 5. So that would be the BFS of this graph. So how do we do it actually? If I were to just describe that a bit, uh, we can't spend much time on that as the main focus is going to be on BFS, as the main focus is going to be on how to find the cycle. So the point is, let's say I start from this is my source, right? So what I do is I take a vertex, right, and then I make a queue, and what I do is I push my source into the queue. So I push my source into the queue, right, and I can also take its parent, so I can push actually as comma p. So let's say for 1 I consider -1 as its parent, so I can just push 1 comma -1 into my queue. And then what I do is all the vertices that are connected to this, right, that is 2 and 3 in this case, I push them into the queue, and before pushing them I pop this current vertex, right? So the way to write BFS is basically that you will push your source first, right, then you will extract the source, right, and extract the source. If you're using a vector of pair, then you can just extract the source by using q dot front dot first, right? So here you will extract the source, this is the source, and if you want to extract the parent, so it is q dot front dot second, right? So now you've extracted the sources and the parents, right, and now you will go for int node. Okay, before this you need to pop it, before this you need to pop this source, so you will just do q dot pop, right? Now after q dot pop, as you have the source, so you will basically scan through all the vertices that the source is connected to, which in this case is 2 and 3. So in the queue you have popped out one, first one was there in the queue, you have popped out one, right? Now you have 2 and 3 in the queue, right? And then you will go to 2, so then the vertices connected to 2 will be written, that is 4 in this case, right, and 2 will be popped out, right, and then you will go to 3, vertices connected to 3, which in this case is 5, so you will write 5, 3 will be popped out, and then 4, and then 5. So that's how basically BFS is done, right? I guess you've got a basic knowledge of how do we implement BFS, right? So now the point is, how will we detect a cycle? So you can just take a pause and think a bit about it, and then maybe we can try. And someone is just wondering, how we end this BFS. So basically the condition we use is while not q dot empty. So unless your queue becomes empty, we continue this process, right? So you would go to 4 and you would find that all, so we definitely make a visited array. If someone knows how to run DFS and BFS, we've definitely done this before. So we make a visited array for 4, this is the only neighbor, and this is already visited. So 4 will have no elements that will be pushed into the queue, and 4 will be popped, and 5 also the same thing, it is only connected to 3 which is already visited. So 5 will be popped, and now your queue is empty, so BFS will end. right? And then so basically if you print each and every element while popping them, you will get this 1 2 3 4 5. This is your BFS, right? If you start from if your source is the first node, right? Okay, so how do we detect a cycle? So let's just see what happens if there exists a cycle. So let's say this is my graph. Let's expand this a bit. So this sixth vertex, the seventh vertex, and let's say these two vertices are connected, right? And we are starting from 1. So what will you do first? You'll first have 1 in the queue, right? Then we'll push all the neighbors. You will have 2 and 3. You will pop out 1, right? So 1 will be popped out, and then you will go to 2. So 2 neighbors of 2, 4, right? 2 will be popped out. So let's erase 2. Then you will go to 3. Okay, no, just made a small mistake. So for 1 you will actually have all of these, no? 2, 3 and 6, right? And 1 will be popped out. Then what you will do after that is, for 2 you will push the friends of 2, which in this case is 4, right? So then 4 will come and 2 will be popped out, and then for 3 you will go to 5, right? But now the problem is, now see what we were doing, we were pushing the source and we were pushing the parent, right? And in case of 4, let's say, when we were seeing, okay, so 3 will popped out first of all. So when we were seeing the friends of any element, so if it was not visited, if it was not visited, if it was not visited, right, then though we were just pushing it, right? If an element, while we run a BFS, like let's say this is your BFS, so like you first go to 1 and then you see 2 and 3 both are not visited in the visited array, so you simply push 2 and 3 in the queue, right? But let's say if any of them is not is visited, is already visited, then what do you check? Like let's say when you run the BFS for 1, so you push 2 and 3, right? And then you erase 1 and then you go to 2, right? Then when you go to 2, you see the only friend is 1, but 1 is already visited, right? Because we are coming to 2 from 1 only, so 1 is already visited. So then what do you check? Whether 1 is its parent or not. Because if 1 is visited and there exists no cycle, then definitely 1 has to be its parent. Because let's take a few more examples and try to understand. If this was our graph, so you can very well see that if, as in this graph, there's no cycle, right? So from 1 you will go to 2, right? Like in DFS, if you are running a DFS, so from 1 you will go to 2, and then from 2 you will go to 4, right? So 4 has only one friend, which is 2, and 2 is its parent. 2 is parent of 4, right? And you can't reach 2 from any other node, right? Now let's say you are able to reach 2, you can't reach 4 from any other node except 2, right? Now let's say you were able to reach 4 from some other node, let's say it was 3. Now you can see there exists a cycle. So basically the whole point of the discussion is that if there exists a node, there are two conditions. If there exists a node that is firstly already visited and not its parent, right, then there definitely exists a cycle. These two conditions are enough for us to detect a cycle, right? Okay, so I think that is a basic understanding. So how, like in the implementation part, if you talk about, so firstly though you will simply push your source, as a very basic thing, right? Then you will go to all of these, like you will push all the elements, right? And how, like what is the condition for pushing elements? It's simple. If not visited of node, if your node is not visited and your node is not equal to the parent, right, then only. Because if you're, okay, no, I think if node is not visited, so like let's take some graph. If your node is not visited, like for instance, let's say 3, so like in this graph, let's say, so let's say we come from here, right? there exists a cycle. So if your node is not visited, then though I think you can simply push it, right? So if a node is not visited, you will simply push it s comma p, like you will make pair, you will definitely use make pair command, right? You will pair it, because we are using vector of pair, like q your q is actually not a vector of pair, it's a queue consisting of pairs as its elements. So you are basically using q pair int comma int, right? That is what you're using. So you will simply push, and the condition for pushing is that if it's not visited. So if it's still not visited, uh, whichever node it is, so you will simply push it, right? And the other condition is else if. So the condition that we're going to put here is that parent wala condition ki if it's visited and it is not its parent, so let's say whichever node it is not equal to p, right? It is not equal to the parent and it's visited, that means you will return true, that cycle exists. So the basic function that we're using is bool dfs, returns a boolean value whether true or false. And when you're done with all these if else's, when you're done with the complete loop, when you're done with all the traversal, right, and you don't return any kind of true statement, right, that means there exists no cycle, so at the end you will return false, right? You will at the end return false and close the function, right? Okay, now there is a simple problem, like let's say we have a few connected components, right? We have multiple connected components, like we could have this kind of a graph now, that let's say 1 2 3 4 5 and then 6 7 8. So there are three different connected components, right? So if you run bfs on 1 comma minus 1, as I said, then you will only cover this and there exists no cycle, and the answer you will return is that in this whole graph there's no cycle, but actually there's a cycle in 6 7 8, right, which is a different connected component. So there you will use for int I equal to 0, I less than n, I plus plus, right? And then if it is not visited, you will run the bfs for each connected component, right? I comma your parent, and parent we are generally choosing -1, right? So you will basically run bfs for each node, right? Okay, so I think that ends all kind of queries that could appear in this question, but there's a new format of this kind of questions, that is which makes it even more difficult. So all that we have done is cycle detection. We have just detected if a cycle exists or not. What they could ask for is also that can you print this cycle, right? So I can just suggest you a question. There's a question called round trip on CSS. This is there on CSS, round trip, right? So you can just see this question. So I'll just brief you the question, and you can think about it and comment a solution. So what we have is we have n different cities, let's say, and we have m roads, right? So what you need to do is you need to start from any city. Okay, you can start from any city, and you need to have a path where there are two or more cities in between, right? Like if you start from this city, so you must have two or more cities in between and end at the same city. So basically you need a cycle. So it's all about cycle detection, but the question also asks you to print these nodes, that which are the cities that you're visiting, right, to get back to the city. So it's all about cycle detection. So what you will do is, if you are able to see that there's no cycle does not exist in the graph, so we'll simply print that it is impossible. But otherwise the challenge is that you have to print the cycle. So maybe we'll make a separate video on this, or you can comment the solution, and there are, if any doubts, you could also comment that. Okay, thank you.